diamonds, they do not have mobility of electrons.
Yes, does not have mobile sea of electron. Can you like okay? Let me ask to other students. Let me ask to Lawrence. Hello, Lawrence.
Yes, teacher.
Yeah, Lawrence, can you tell us what is the bond angle in diamond?
Uh,
Bond
Wait, teacher.
angle.
Let me look for my answer.
Yeah.
Let me look for my answer.
Yes.
The bond angle for which one?
Diamond. The bond angle of carbon in diamond.
Uh,
What is the shape of?
one tetrahedral.
Yes, the shape is tetrahedral. The bond angle is
109.5 degrees.
yes 109.5. How about graphite, Lawrence? What is the bond angle of carbon in graphite?
Uh, Graphite is planar.
The shape is planar. Or what planar? Square planar or trigonal planar?
Uh, mm, I think it's uh, trigonal planar.
Yes, trigonal planar. So the bond angle is
120 degree.
yes 120 degrees. Okay. Timothy. Hello, Timothy.
Yes, teacher.
Yeah. Can you tell us what is the structure of diamond and graphite?
For the structure of diamond, each carbon atom is joined to four other
Yes.
carbon atoms by strong covalent bonds.
Yeah.
The shape regular tetrahedral structure and doesn't have free electrons.
Yes.
And it can conduct electricity.
Diamond does not conduct electricity.
Oh,
Then
sorry, yeah, sorry.
yeah.
Doesn't conduct electricity.
And what is the structure? Is it giant covalent structure or simple molecular structure?
Giant covalent.
Giant covalent structure. Correct. How about graphite?
For graphite, each carbon atom is joined to three other carbon atoms.
Yes.
They form layers of hexagonized rings and has one delocalized electrons from each atom.
Yes. Correct. And then the layers of hexagon are connected to different hexagon. What is the intermolecular forces, Timothy?
Mm,
What is the intermolecular force? What is the intermolecular forces between hexagon layers?
Van der Waals.
Yes, correct. Van der Waals. It is impossible to have hydrogen bonding. Okay. Now number two, iodine and diamond are both solids at room temperature. Identify one similarity in the bonding. Already answered. It is the covalent bonding, and then also one difference in the structures. Timothy just told us the structures in but in diamond, not in iodine. Now let me ask to Felicia. Hello, Felicia.
Yes, teacher.
What is the structures in iodine molecule?
Iodine has a simple molecular structure.
Simple molecular structure. Okay. What is the intermolecular forces?
It has weak van der Waals forces.
It has weak van der Waals forces. Okay. Is it instantaneous dipole or permanent dipole forces?
Instantaneous.
Instantaneous, correct. So if they have different melting points, so we have to see from the uh, intermolecular forces. And then next number, there is a white phosphorus and red phosphorus. White phosphorus and red phosphorus came from the same element, it is phosphorus. And then so this phosphorus, red and white, they are called as an allotrope of phosphorus. We know that the white phosphorus has low melting point, that makes it has simple molecular structure, and then while red phosphorus has giant molecular structure. Okay, so the question is asking for macromolecular, of course you know, and then about the melting and boiling point, of course you know. Now next number, predict the shape of the sulfur hexafluoride. Of course you know already the bond angle and the shape, and then also AlCl4 negative. So you know how to draw how many bond angle, how many bond pairs, how many lone pairs, and then what is the bond angle, what is the shape of the molecule, of course you know. And then perfume, this one also there is a process of diffusion in number 4. And then in number 5, iodine and graphite. So in number 2 was about the iodine and diamond, but in number 5, iodine and graphite. And then about the electrical conductivity, and then drawing the shape of BeCl2 and explain why it has this shape. Okay, so before I discuss again, let me take attendance for 11S. Let me take attendance for 11S. This 11S, let me see from the list. Ariella, Beatrix, Bavia, and then Brian's, Sherry, Clarabella, Eric, Ezekiel, and then Felicia, Hardy, Kimberly, Lawrence, Michelle. Oh, Matthew is absent. So Michelle, Nargis, and then Natasha, Nathan V, Timothy, Tisel, Vanessa, Vedika, and Sharon is here. Okay. So I have prepared the discussion for this worksheet. As you notice, I give worksheet 2 and worksheet 3. Worksheet 1 about the calculation. Maybe we are going to have it on Monday. For sure, tomorrow there will be no holiday. No holiday during the weekend. Discuss the worksheet of yesterday about the solid, liquid, and gas. Okay. Let me share it with you screen. Okay, this one. Let us discuss the worksheet of yesterday about the solid, liquid, and gas, especially about solid and liquid. We know in solid and liquid there are some structures, simple molecular structures, giant molecular structures, lattice structures, and then also giant ionic lattice, and then metallic lattice. Okay, so let's see in this one. This worksheet is specially made for grade 11 for solid liquid only. Let's see number 1. Diamond and graphite are both forms of carbon. Diamond is able to scratch almost all other substances, while graphite may be used as a lubricant. Diamond and graphite both have high melting points. Explain each of these properties of diamond and graphite in terms of the structure and bonding. So in this one, the question is asking specific to the terms and bonding of diamond and graphite. Give one other difference in the properties of diamond and graphite. Okay, in structure and bonding, we know in structure, diamond is hard. So let's discuss from the perspective of structure and hardness. Both of them are macromolecular, giant covalent network. The difference is in diamond, the carbon atom, one carbon atom, is joined to 4 different carbon atoms. It forms a tetrahedral shape with bond angle of 109.5 degrees. The coordination number is 4. How come coordination number is 4? Because around carbon there are another 4 carbon atoms. And then in graphite, one carbon is surrounded or bonded to other 3 carbon atoms. And then because there is one half lone pair, and there are 3 bond pairs only, with only half lone pair. So we can call that this shape of the molecule is trigonal planar. Because one carbon is surrounded or bonded to other 3 carbon atoms, so we call this structure has coordination number of 3. And then diamond is a crystal, and then it is strong. It is stronger than graphite. And then according to the 3D structure, that we used to learn in grade 9, diamond has tetrahedral shape, but tetrahedral structure, but in graphite has layers of hexagonal. The layers are connected by van der Waals forces that makes the layer able to slide over each other, and then this graphite is not as strong as diamond, but it has high melting points similar to diamond. Why? Because both of them have a giant covalent network, and then giant covalent network requires high temperature to overcome the strength of the covalent bonds. And then one more difference that we already learned in grade 9, diamond cannot conduct electricity, but graphite conducts electricity because there is a free electron. In diamond, all the electrons are occupied, so there is no free electron. Okay, now let's continue to number 2. Iodine and diamond are both solids at room temperature. Okay, this is a fact. But iodine is volatile solid, which is at higher temperature, it can evaporate directly. But diamond in temperature maybe 100, still not yet become anything, still solid. It does not become liquid or become gas, different from iodine. Identify one similarity in the bonding and one difference in the structures of these two solids. Explain why these two solids have very different melting points. Okay, let's see from the perspective of the bonding. Both of them, diamond and iodine, they have covalent bonding, the intramolecular forces. The difference is in the structure. Iodine has a simple molecular structure because it has lower it has a lower boiling and melting point compared to diamond. Diamond has very high melting and boiling point that makes it has a giant covalent network. It has strong covalent bonds, but in terms of the bonding, both of them have the same covalent bond. And then iodine has a instantaneous dipole, or called as weak van der Waals, or called as induced dipole forces, because iodine molecule has no electronegativity difference. One iodine atom has a certain electronegativity which is chemically combined with the other iodine atom that has the same electronegativity value. So when they combine chemically, there is no electronegativity difference. If there is no electronegativity difference, then this iodine molecule has an instantaneous dipole forces that makes it has a low melting and boiling point. While diamond has a giant covalent network, it has the tetrahedral structure that has a strong bonds, so it requires high temperature to overcome the strength of the bonding. Number 3. Phosphorus exists in several forms, two of which are white phosphorus and red phosphorus. White phosphorus consists of P4 molecules, melts at 44 degrees Celsius. Red phosphorus is macromolecular, has a melting point above 550. So these two phosphorus came from the same phosphorus but different forms. So we can call this one is an allotrope of phosphorus. So here we can see from the first sentence here that white phosphorus has a simple molecular structure because it has low melting and low melting point compared to red phosphorus. Red phosphorus has a giant covalent network because the melting point is more than 100 degrees Celsius. So the question is asking, explain what is meant by the term macromolecular. We know what is meaning by macromolecular is giant covalent network. It forms a giant covalent structure or giant structure. By considering the structure and bonding present in these two forms of phosphorus, explain why the melting point are so different. Melting point, as we know, as I told you, that that white phosphorus has a simple molecular structure, while red phosphorus has a strong giant covalent network, and it has and white phosphorus has simple molecular structure. It has weak van der Waals, but in red phosphorus it has also van der Waals, but stronger van der Waals. Okay, number 4. predict the shape of sulfur hexafluoride molecule and AlCl4 negative ion. We have to draw the diagram of each species in their three-dimensional shapes. Name the shape and suggest the value for the bond angles. We know that as in SM6 has a shape of octahedral or square based by pyramid, not square pyramid, but square based by pyramid. So there are square based pyramid joins together become angle of 180 and 90 degrees. So the shape is like this. We know that it has M6 6 wood pairs and without M pairs. And then in AlCl4 negative, the shape is like this. These are Al atoms, atom center. There are 4 here. And then the shape is tetrahedral with the bond angle of 109.5 degrees. Okay, and from the AlCl4 here, we know there are 4 bond pairs and without any pairs. And then B. Perfume is a mixture of fragrant compounds dissolved in volatile solvent. When applied to the skin, the solvent evaporates, causing the skin to cool for a short time. This one, what is the volatile solvent? Is alcohol. After a while, the fragrance may be detected some distance away. Explain these observations. The fragrance may be detected some distance away. It is called as diffusion process. Okay, and then because it has a volatile solvent, so the solvent has low melting and boiling point. If it has low melting and boiling point, then it must have a weak intermolecular force. What is the weak intermolecular force? It is the weak van der Waals. Okay, and then so the process is, why is it cool? Because there is a endothermic. Higher energy or faster molecules directly escape, so the mean energy falls. So that makes the energy taken from the skin, so it cools. We know that endothermic is energy given in to the surrounding. Okay, given in the surrounding.